My name is Venkat Gattamneni. I'm a product manager with GCE, and welcome to the session. It's an introductory session on running Windows Server containers in Google Kubernetes Engine. And presenting with me are Yuju and Alex. I'll let them introduce themselves quickly.
Hi, I'm Yuzhu. I'm a software engineer at Google. I have been working on Kubernetes and GKE for the past 4 years. Most of my work is about node and container runtime. I'm happy to be here today to introduce you to Windows Server containers on GKE.
Hi, my name is Alex Jankolski. I'm a software architect with the data science and analytics team at Baker Hughes, a GE company. I'm a GCP customer.
Awesome. Thank you so much, Yuju and Alex. Before I we go into the session, I just want to do a bit of an audience poll. Just show of hands, how many of you are using containers already? Awesome. And how many of you are sort of new to containers, still kicking the tires a little bit? Great. How many of you are using Windows Server containers? Okay, okay. Okay, that's totally fine. And how many of you are excited to be here to learn more about Windows Server containers in GKE? Yay, okay. We're all in the right session then. Awesome. Okay. So what I'll do by way of agenda, what we'll do is we'll go, so this is an introductory session like I said before. We'll go into a little bit of a quick overview of Windows Server containers, and then we'll talk about at length about Kubernetes and GKE and running Windows Server containers in GKE. But before we get into the technical details, what I wanted to do was hear from Baker Hughes, who is one of our largest customers for GKE, and they've been on a multi-year journey to transform themselves in using containers. So let's hear from Alex as to what they're doing at Baker Hughes and how Windows Server containers fits into their journey and strategy. Alex?
Thank you, Venkat. And I really appreciate the fact that you're letting me speak first. As GCP traditionally does, they put their customers first. So just to give a little bit of business context, BHGE is the world's first full-stream company. That means a full-service oil and gas business. We have about 66,000 employees and operations in more than 120 countries. Being full-stream means that we deal with challenges across the full spectrum of services in the oil and gas industry, from exploration to production, transportation, and operations. We see and operate a lot of mission-critical equipment and complex systems that produce an ocean of data. We like to say that we operate and our challenge is in the intersection of data science, software, and domain knowledge to help us build accurate models from that data and extract insights that make and help us make very high impact and critical business decisions. For example, a typical oil rig produces terabytes of data per day. It can have upwards of 20,000 sensors that give information to us every couple of seconds. And our models cannot have an impact that would cause us to falsely shut down that oil rig for a day, because that would equate to about $10 million in lost profit. Traditionally, the oil and gas industry has been a data-rich industry, but that data is spread around the business in silos. There is a huge variety of code and technologies that have been used in the industry over the past 30 years. And we have analytics that have been proven in the field. But that over time has accumulated a technology stack that starts from Fortran 77 all the way to today's world where we have Node.js, Go, .NET. So somehow all of these analytics need to work together. They have to be orchestrated together, pass data from one to another, be orchestrated in loops. That's a huge challenge. The thing that makes it possible and easier for do that are containers. If you'd like to learn more about how we run these analytics in containers, how we orchestrate them at scale, I invite you to join me at this breakout session tomorrow, where we're going to dive deeper into that. And here are some examples where we see specifically use of Windows-dependent executables. So we have legacy DLLs and old compiled executables. One example is this Steam thermal model. That's a Windows executable from '95. And aren't spreadsheets great? I mean, people today still do analytics in Excel. Another good example is this refinery simulation software that we were trying to modernize. And we were able to actually transform part of it into Linux container, wrap a web UI around it. But there's this one part that is impossible to change, and that is the licensing server that only runs on Windows and has to run on that platform. We were able to put it in a Windows container. So I wanted to come on stage here today so I can say this. Ladies and gentlemen, I have a dream. I dream of a day in the future where we can say all containers are created equal. And at BHGE, we created this project called Depend on Docker, which makes it easy for our data scientists to containerize both on Windows and Linux, anything that they're working on. We've open sourced this. Please check out the GitHub. But that is not enough. The Windows and Linux containers that we build need to work together, side by side. And we need this one orchestration system that is going to do that for us. So let me leave you with the words of John Lennon. You may say I'm a dreamer, but I'm not the only one. And with this, let me pass the mic back to Venkat and Yuju from the Windows GKE team so they can tell you how they're making all of this happen.
Thank you so much, Alex. Let's now talk about making Alex's dream a reality, shall we? Awesome. So, but jokes aside, outside, of course, making sure that we are listening to customers and bringing Windows Server containers to GKE, this is also part of our long-standing commitment to make sure that Microsoft workloads get a first-class experience on GCP. And this is a statement that you see made by our SVP Urs, that we are really committed to making sure that Microsoft workloads are a first-class citizen on GCP and, of course, GKE as well. Now, for those of you who said, hey, you're still early in considering Windows Server containers, here's a very quick overview of Windows Server containers. For those of you who've been doing this for a while, this should be obviously very familiar. It's often good to think of containers in the context of virtual machines if you're new to it. On the left-hand side is what I presume everyone in the room is familiar with, right? Virtual machines. Typically, virtual machines were invented to virtualize the underlying hardware or the infrastructure, so much so that each of the OS and the application running on top of the OS pretty much thinks that it has the hardware to itself, and that was the technology of hypervisor. Now, containers is somewhat similar, so it's good to think of containers in that context, where the application and the dependent binaries that the application depends on essentially is the container, the red box that you see on the right-hand side. And those, of course, many of those containers can run inside of a virtual machine in GCP. Essentially, containers are virtualizing the underlying operating system, so much so that the application thinks that it has the OS to itself, whereas in reality, we all know it's not. So that's kind of like a quick overview of what containers are. And in the world of Windows Server containers, they're very similar to Linux containers. Of course, there are a couple of differences that we'll kind of highlight in the next few slides. But you want to think of a Windows Server container on the right-hand side as consisting of several layers. Typically, inside of a virtual machine, when you're running a Windows Server container that's in the red box, there's, of course, a host OS, right? That's a Windows Server host OS that's running. On top of that, there's a container runtime like Docker. And on top of that runs your Windows Server container. And a Windows Server container, like you can see here, is composed of multiple layers. Typically, there's a base OS layer image at the bottom, obviously. And above that, there are a number of custom layers that you can add on top. It can be IIS, PowerShell, et cetera, right? A lot of things you can add on top of the base OS layer. And then on top of that sits your application. That, in a sense, is really how you make containers, right? Windows Server containers. That's what that was. Hopefully, that was a quick overview for those of you who are early in the Windows Server containers land. Now, as you make choice of your Windows Server containers and you make those containers of your applications, there are a couple of things I wanted to kind of run by very quickly. The first thing you'll be doing is selecting your underlying host OS. Now, as many of you may know, from Microsoft, there are two releases or two channels that Microsoft has for Windows Server. One they call long-term service channel, and the other is called semi-annual channel. LTSC examples of that are Windows Server 2016, 2019, and so on. And of course, on a semi-annual channel release schedule, these are released every 6 months or so. So the latest one is 1809, and usually the numbering or the build numbering for that follows the year and the month after that, right? So that's the key difference between those two releases. A couple of quick things to note there. If you are looking into containers, I'll point out the support that Microsoft provides for either of them is a little bit different. So you want to make your choice for underlying host OS based on that, if that's of importance. But that said, there's a lot changing with server containers. In fact, updates are being released on a very frequent basis. So the recommendation from Microsoft is obviously to use the semi-annual channel for your container applications, because then you can keep up to date with all of that good tech that's coming out and rolling into these semi-annual updates, right? So that's kind of a little bit about choosing the underlying host OS. Now, going one layer up, as you're choosing your next layer of your Windows Server container, you have to make a choice on what kind of a base image you want inside of your container. There are two broad types of base images that you can choose from, the Windows Server Core and the Windows Nano Server. The key differences between them are, of course, one is of size. For those of you who may know, Windows Server Core, when you download from the registry, is a little over 2 gig, and of course, uncompressed, it can go up to about 5 gig, right? Windows Nano Server, on the other hand, is very tiny, almost compares to Linux container sizes. When you download, that's under 100 meg now, and of course, when you explode that up, it's a little bit over 200 meg. Now, the scenarios where you'll be choosing either or are going to be dependent on your applications. If you want a lot of compatibility for your legacy applications with the older stuff, you want to go for Server Core. Of course, a lot of the new applications like .NET Core, IIS, ASP.NET, et cetera, will do just fine in Nano Server. The usual rule of thumb is go with Nano Server. If for some reason, compatibility reason, you cannot, of course, go down the left side, right, with Windows Server Core. So hopefully that's a little bit of a tip on choosing the next layer for your Windows Server containers. Now, one of the things that is kind of like a little bit different in the world of Windows Server containers versus what you may have been used with Linux containers is that you must make sure that you have to match the host and the container OS versions. So this is just a bit of a gotcha if you're especially coming from Linux world to kind of like make sure those two match. And when it comes to Windows Server numbering system for versions, there are 4 numbers, right? There is major, minor, build, and revision. Now the first 3 are the ones that have to match. The last one, it's okay for it not to match. The revision number is typically a number that gets updated every time you apply a patch, like a KB patch to your image, right? So that's the key difference. Just to illustrate a quick example, let's say if you have a container image and a host OS version, and those are the versions that they're running. If you end up, let's say, upgrading or rather applying a patch update to the host OS version, and you don't update or apply that same patch to your container image, it'll just work fine. However, if you upgrade the underlying host OS, let's say to the next build, and you do not do that for the container, it just won't run, right? It just won't even start, so, right? So just kind of like something to remember as you're thinking about what version to choose and how to mix and match your container and host versions. Now, we get a lot of these questions from customers also on licensing, right? How does licensing work for Windows containers? So I just wanted to spend a minute on that. Now, the way Microsoft treats container licenses is that they are supplements to the underlying host OS licenses. What that basically means is if you are running a licensed host OS inside of a VM, you can run containers, right? Your license actually covers for that. So the good news is in GCE, as long as you're spinning up your Windows Server VMs, you're already licensed for, because you're paying for the license on the underlying sort of virtual machine, you can run any number of containers on top. And because Windows Server 2019 Data Center and Standard Editions allow you to run unlimited number of Windows Server containers, there's a ton of savings you can actually get by packing a lot of those containers on one OS. The other key point I want to sort of mention here is if you are running containers on top of a host OS, you can only do that for running containers. So you can't have some containers and have something else run on top also. That's what on the right side of the slide it says, right? It has to be used solely to run containers. So that's kind of like a licensing term as well. So hopefully some tips here on licensing. Now, of course, we get a lot of questions from customers. Many of you are thinking about how to basically containerize, what to containerize, what not. Those are all great discussions, and it's hard to come up with a prescriptive guidance for that sort of a question, honestly. Just now you heard from Alex as to the journey that they have embarked on, especially as they sort of modernized and containerized their applications, and your journey could be very similar or very different, honestly. In many cases, what I do recommend to customers is that have a bit of a checklist that you prepare for applications and have some criteria by which you assess those applications, whether they're containerizable or not. And some, of course, tips are here on the slide. Great candidates for containerization generally are your web and logic tiers, in-house .NET apps if you've got custom apps that you developed yourself because you know the code and you can containerize them. And of course, slightly more recent applications that are perhaps IIS 6+ or 3.5 .NET framework and onwards. And of course, new applications that you're developing using microservices architectures and or cloud-native applications also make for great candidates for containers. Now, some of those applications that you want to stay away from for a little bit at least is any application that has UI experience, right? Because containers won't give you that. RDP, VDI are examples kind of like to stay away from for now. And especially if there's an underlying dependency your application has on GPUs or TPUs or any low-level networking constructs out there, you want to kind of like look at it a little bit more closely before you decide to containerize. And of course, with AD integration, that's something that's in the works. So I would say keep looking out for that. Upstream Kubernetes has that in alpha support, and of course, we will have plans to support that as well. But that's something to absolutely keep on lookout for. One thing I'll mention here is that any of the things that are important to you that are on the right-hand side, do talk to us because the world is changing very quickly. We're adding a ton of innovation, as is Microsoft as well with containers. So we're all listening to your feedback, so keep talking to us. Now, outside of that, in Google Cloud, we've been, of course, supporting Windows Server containers for a while. If you go to your management console and open up the menu, there are a number of images already that you can get started with today. And if you choose one of these container optimized images for Windows Server, they come in with Docker pre-installed, right? So you don't have to install Docker yourself. They're ready to go. And they have server core nano server images already downloaded and loaded up in the local registry inside of those virtual machines. So if you want to give it a spin, immediately you can do so without having to download them on the wire again. And then, of course, GCP does have a cloud registries for you to kind of make modifications if you want those container images, push and pull those images at your will, which, of course, is going to be a lot more important as you look at Kubernetes and the GKE, of course, as well for your applications. And if you're interested in learning a little bit more about, how do you take a .NET application, containerize it, et cetera, there is a session that we're running later today. We'll go into a little bit more of depth and show a demo as well for that. Now, obviously, that was a whirlwind tour of hopefully Windows Server containers, hopefully some tips and tricks for those of you who are very early in this journey with us. Now, let's shift our attention to talk about orchestration with Kubernetes. Usually, we'll be covering a little bit about Kubernetes and then talking about our plans to support it in GKE. Yuju? Sorry. Thank you.
Yeah, thanks, Venkat. So in the next part, I'll be walking you through a high-level overview of Windows Server containers with Kubernetes, and then with GKE, and then I'll wrap it up with a demo. So if you don't know about Kubernetes already, it's the leading container orchestration system out there. It helps you automate deployment of your applications, managing their life cycles, and scaling your applications as needed. So this technology was actually inspired by Google's experience of running billions of containers internally over the years. And it's completely open source and runs in multiple clouds. So here's an oversimplified view of Kubernetes architecture. At the bottom, you have the worker nodes, which are typically virtual machines running your workloads. And then you have the master control plane at the top. That includes API server, scheduler, and various controllers. So a Kubernetes user would just write a workload specification indicating how many replicas they want, what kind of container image to use, and then submit this spec to the API server, which will get dispatched eventually onto the worker nodes. And then we have the per node agent, which is Qubit, that will start up the containers and manage them for you. So Kubernetes started with Linux containers only. But in the past 2 years, the community has been working closely with Microsoft to support Windows containers. So I'm happy to tell you that just in the last month, in the Kubernetes 1.14 release, Windows Server containers running on Windows nodes were declared as a stable feature. So kudos to all the community members who helped to make this happen. So how do Windows Server containers work in Kubernetes? So let's see an overview of this. So here we have the architecture again, and you have the master control plane. So this master control plane will still run on Linux. Currently, there's no plan to make it run on Windows. But then you can add Windows nodes. So those worker nodes will be running on Windows Server 2019, which is a requirement with the 1.14 release. And then on those nodes, we again will have per node agents running. So with the Windows nodes, now you can run Windows pods. So pod is composed of multiple containers. It's a basic scheduling unit in Kubernetes. A pod containers in the pod share a single IP address. They can share volumes to access the same set of data. And users can customize their pods to use custom hooks or health checks. And also, a pod can access config maps or secrets, which are Kubernetes concepts for configurations or storing of sensitive information. And then, of course, you can view the status and getting the events and metrics for your Windows pods, as you can do for your Linux pods. So with pods, now you can build services. A service in Kubernetes groups multiple pods with a defined access policy. For example, as shown on the slide, you can have a service with a single IP address, and then you can actually have 3 different pods to back this service. So the traffic would get distributed onto those 3 pods. So Kubernetes supports multiple types of services or load balancers, and we support this for both Windows and Linux pods. So this provides cross-platform connectivity. So we talk about pod, which is a very basic concept in Kubernetes. But most users don't create pods directly. They create higher-level construct that better suits their workloads. For example, a daemon set would create a pod per node. Or if you use job, it will ensure that a number of desired pods will run to completion. And then we have stateful set, which provides stable network and storage identity for each pod in the set. This is particularly useful if you are accessing a persistent storage, and if the pod crashes, or if you recreate the pod, you want the pod to assume the same identity and access the same piece of storage. So these are all supported for Windows pods as well. So we've only touched upon the basic concepts in Kubernetes and what's supported for Windows containers. There are so many other features that are already supported for Windows containers. And again, there will be some features that do not work for Windows pods yet. And it could be due to the inherent limitation on Windows kernel and the platform, and also, or just because the concept does not exist on Windows at all. And you will find, in some cases, even though a feature does work for Windows, the behavior on Windows pods there might be a slight behavioral difference between Windows pods and Linux pods. So there are things to watch out for. And of course, the community is continuing working on rolling out supporting different features, and many more will be coming in the next few releases. So that's one incentive to keep your Kubernetes cluster up to date. So if you are curious and you want to find out more about what features are supported, you can check out the link on the slide. This is a documentation maintained by the Kubernetes community. It will get updated frequently. Or if you don't trust documentation, we also have continuous testing. This is our open source testing dashboard that's running Kubernetes on Google Kubernetes Engine for Windows Server containers. It runs regularly every couple of hours, and you can clearly see what's working and what's not. So Kubernetes is great, and many people love it, and it's widely used. But a lot of users want to focus on developing their applications, not managing the Kubernetes cluster, figuring out the operational logistics day-to-day. And that's where GKE comes in. GKE provides a fully managed master control plan. So you don't have to worry about the downtime of your API server. You don't have to resize your master control plan just because you want to scale your workload or adding more nodes into your cluster. GKE also monitors the health of your nodes and provide auto-repair mechanism if you want it, and offer different options for upgrade. There's also logging, out-of-box logging, monitoring integration, and a lot more integration with other Google Cloud services. So we are working very hard to bring Windows container support to GKE so that you get to fully experience GKE and while running both Linux and Windows workloads. So here's a preview of how Windows Server containers will look like on GKE. So again, the architecture diagram, but this time we have the managed masters in the cloud. So that just means you don't have to worry about it. You don't need to care about what's actually running in it right now. And in GKE, there's a concept called node pool, which basically is just a group of nodes with the same configuration. For example, the same machine type, the same OS image. And so far, we've only been supporting Linux node pools. We'll be adding a Windows node pool support, meaning that you could just add the new Windows node pool into an existing cluster. And then you can run mixed Windows and Linux workloads in the same cluster. So you may be wondering that, but what would happen to my Linux workloads? Would they get scheduled onto those Windows nodes and fail to run? So to prevent that from happening, we'll be tenting the Windows node automatically. So tent is a common mechanism used in Kubernetes to steer the workloads away. So any workload that cannot be run on Windows will be automatically assigned to Linux nodes. This ensures a backward compatibility for your workloads. So if you just want to create a pod that runs on Windows, what would you do? So in this case, all you need to do is to add a node selector to target Windows nodes. And in GKE, we will add the toleration for you so that it can get scheduled onto Windows node. And remember that I mentioned previously that some of the features work for Windows, some don't. And it's actually a very complicated process and documentation to look through. To help with our users, we'll also be validating the fields in the path spec, making sure that the features you are using are actually supported. And if not, we'll reject right away so that you know what's going on with your workloads. So enough with the talking, and let's see it in action. So I'll be doing a demo with a GKE cluster today. And sorry, can you go back to the slide? Can we switch back to the slide 1 second? Yeah, so this is an overview of the application I'm going to deploy today. So the application includes 2 parts. One is a web server hosting a movie information. This is an ASP.NET Core application, an example that I borrowed from Microsoft. And then we'll have a database that's running SQL Server Express database. And for this, we'll be running it in a stateful set, and we'll be accessing a persistent storage. In this case, that would be a persistent disk in GCE. So these 2 services will share their credentials, the database credentials, through a Kubernetes secret. So let's switch to the demo and to see what's going on. So to save us some time, I already created a GKE cluster. The name of the cluster is demo, and it has 6 nodes right now. So let's see what's actually in it. So if we scroll to the bottom, you can see there are 2 node pools. The first one is the default node pool, which runs COS, our Linux image. And the second one is Win, which runs Windows. And we can click on it and see that it's using Windows SAC image. And we have already a tent that's already applied to the node. And let's go back to the cluster and deploy the workload. So you can, this is another view from using a kube control, which is a Kubernetes command line tool that shows that we have 6 nodes right now in the cluster. So I'm going to run a simple script, which is just going to deploy the specs that I have in this directory. So it's not doing any more than that other than just submitting those specs to the API server. So while we are waiting for the application to create, we can actually see this in our Cloud Console. So we can see the paths are pending, still trying to create it, but that's fine. We can actually see the spec of this. In this case, this is the database part. So you can see that it's a stateful set. And in the spec, we have environment variables, which populate and gets the secret references and populate environment variables for the container to use. And this is running MS SQL Server Windows Express. And then we have the resource limits and requests, which are always good to have to ensure that your node is not overcommitted. Next, we have the volume mounts. So this is the part where we want to mount the persistent storage into the container to make sure that we can store our data, our log, and our backup onto a persistent storage. And then we have the node selector, which is a part that I just mentioned in the slide that to indicate that this is a Windows pod we want to run on Windows nodes. OK, so let's go back and check our workload. Seems like everything is good. And let's check the script. It says everything that has been deployed. So we can try and see if we can access the website. OK, So it works. Now we are. So we have this movie website. We can see the details. Details of the movie. We can actually edit it, and everything will be saved onto the GCE PD so that you can recreate a new part and access the same set of data. So this is all good, but what if it doesn't work? In a lot of cases, that's where the problem starts, that your application doesn't work as expected and you want to troubleshoot it. So first of all, we can click onto the database and the part in this service and actually see the CPU and memory usage. So it only has a slight dot right now because we have only been running this part for a short while, but it will gather more data so you can easily see what's the resource usage of your part right now. And then if you want to use Kubernetes command line tool, that's also fine. So we can, for example, access the logs of the database right now. So you can see it's running, they have some error message, but it seems to be fine right now. And then if you want to troubleshoot further, you can also log in. You can also exec into the container. So right now we are inside the PowerShell inside the database container. So for example, I can run PS and see what processes are running. We see the SQL Server, SQL Writer, etc. And we can also try to access the database locally. So from now on, you can use SQL command. You can write SQL queries. So, yep. Let's switch back to the slides. So we'll be launching an early access program soon in 2019. So if you please sign up for our EAP program. You will get a chance to actually influence our product at the early stage and to make sure that we are building what you actually need. So let's hand it back to Venkat to talk more about the opportunity this brings to you with GKE support.
Thank you so much, Yuji. It's awesome. Thank you so much, Yuju. I'll leave the slide at the end as well so that you can take pictures and then, of course, sign up for EAP. I'm sure all of you are excited to be joining our EAP program. I wanted to just spend maybe a couple of minutes on talking about the opportunity ahead of us. As we talk to customers, it's very clear that you guys want to run your Windows Server container applications with GKE. And some of what we're hearing from all of you is that it's a great migration path for your older legacy applications. If you're especially running on older versions of Windows Server, Server 2008 is going to go end of life, end of service by January of 2020. Many of you are looking at opportunities to take those applications and modernize them. So this is a great opportunity for you to containerize at the same go without just having to update and upgrade the underlying operating system. Of course, with workload consolidation, you can make sure that by increasing density using containers, you can save on the underlying infrastructure costs as well as save on the licensing costs, right, that we talked about earlier. And of course, I know many of you spend a lot of time on patching and managing your operating systems underneath. So with the management, with the GKE, a lot of that sort of overhead goes out of the picture, which is awesome news for all of us. And for many of you who are embarking on new transformation initiatives, modernization initiatives at your organizations, this is a great way to kind of modernize those applications, right? So tremendous opportunity ahead of us with Windows servers now coming onto GKE. Let's talk a little bit about next steps in terms of how, if you are very new to GCP, you're not yet on GCP, I would encourage you to sign up for a trial account. Take Windows Server containers for a spin and get familiar with the Windows Server containers world a little bit. And of course, we talked about how you can sign up for the GKE Windows Server Container Support EAP. Do sign up for that if that's of interest. I'm assuming by the excitement in the room, many of you are going to be excited joining that program. And of course, we have a number of other sessions here that we're running on learning a little bit more about Windows workloads on GCP at large, or GKE related sessions, as well as a couple of others that we thought would be of interest to you.